Welcome back, students, to my channel. I hope you are doing well and exams are coming nearer and nearer day by day. Okay, so without wasting time, let us continue with the previous questions. Previously, the first 15 questions I have already discussed. You can watch my other which YouTube videos. Okay, right. Question number 16: a body of weight W is projected vertically upward from the Earth's surface to reach a height above the Earth which is equal to 9 times the radius of Earth. The weight of the body at that height. So we'll be using the general formula, students. Okay. The diagram will not be as per scale, okay, because I don't have that much space here. The height is equal to 9 times the radius. Height is equal to 9 times the radius. At this height, we have to find the weight. I'll take this as W dash, whereas here the weight is given as W. Now, weight is equal to m into g. So even though mass remains constant, weight will directly be proportional to acceleration due to gravity. So in that case, the new weight, the factor of change for weight will be same as that for g. So just as we have the formula, the new weight is equal to new acceleration due to gravity is equal to initial acceleration due to gravity into r upon r plus h whole square. Similarly, we can write here W dash is equal to W into R upon R plus H whole square. Same way. Now H is equal to 9R, so this will become 10R in denominator. So finally we have W by 100. So W by 100 is the correct answer, B option. Then moving to the next question. Under the same load, wire A having length 5 meters and cross section area this much stretches uniformly by the same amount as another wire B of length 6 meters and a cross section of this much. Okay, the ratio of the Young's modulus. Now, in these kind of questions, see, try to understand, students, the way I am solving, you are supposed to solve in the same manner, okay? Always. Suppose this is the wire, you have a load here, okay? The load is mg, whatever be the mass, length is L. Now, cross-sectional area is A, and the change in length is smaller, let us say. Then we have the basic formula, stress is equal to Y into strain. Stress is equal to Y into strain. So stress is the restoring force per unit area multiplied by, remember, restoring force per unit area is nothing but mg at equilibrium, and increase in length by small capital L is the strain. Now let us see what all things are constant. Okay, just check what all things are constant under the same load. That is, in both the cases, load is the same. Then stretches uniformly by the same amount. Stretches uniformly by the same amount. That means change in length is also the same. So now we have to find the ratio of Young's modulus. So here I can write Y as L by A into restoring force by increase in length. Since these two are constants, I can write Y is proportional to L by A. So accordingly, I have ratio of Young's modulus will be ratio of their corresponding lengths upon A2 by A1 because it is inverse. So L1 by L2 is how much? L1 is 5, L2 is 6. Then A2 is 3 into 10 to the power minus 5 meters square, whereas A1 is 2.5. 2.5 is actually 5 by 2 into 10 power minus 5. So you can see all the factors get cancelled. 5, 5 gets cancelled, 3 to the 6, 6, 6 gets cancelled. Finally, we have 1 is to 1. First option, A option is the correct answer. Then, moving to the next question, 1000 droplets of water of surface tension this much having same radius, each combined to form a single drop, then in the process, the surface energy released. Now, as you know, that when 1000 droplets would combine, okay, to form a single drop, the surface area reduces. So, when the surface area reduces, automatically the surface energy reduces because surface energy per unit area is a constant which is equal to the surface tension of the liquid. So, as area decreases, surface energy decreases. So, that means the excess energy must be released in some form or other, mostly in the form of heat. So, that means the released surface energy will be equal to the decrease in area multiplied by surface tension. Okay. So, we have to find the decrease in area. In order to know the decrease in area, we should know the relationship between the radii of the water drops, initial and final. So let us calculate that. So here 1000 droplets, of course there must be identical 1000 identical droplets combined to form a single drop. Let us say radius of each droplet is smaller and radius of the bigger drop is capital R. Okay. So here, for now, let me take this as n number of droplets. So have total volume of all the droplets put together will be this. That must be equal to the volume of the single big drop formed after the combination. So from this, we can see that capital R is smaller into cube root of n. First, we have to cancel this 4 by 3 pi. Okay. Then let us find the decrease in area. Decrease in area will be initial minus final. Okay. So initial area is how much? Initial area is n times of area of each smaller droplet, that is 4 pi r square, minus final area is 4 pi capital R square. Okay. Now 4 pi can be taken common and capital R can be replaced by this. So in that case 4 pi r square can be taken common. We have n minus n to the power 2 by 3. So the required released energy will be this decrease in area multiplied by surface tension. So energy released will be decrease in area multiplied by surface tension, that is 4 pi r square into n minus n to the power 2 by 3 into surface tension. So 4 into pi, we have to take pi as 22 by 7. Radius is given as 1 millimeter. You can see it is 1 millimeter. So 1 millimeter square is 10 power minus 6 meter. This is 1000 and cube root of 1000 is 10, square of 10 is 100 into surface tension is 7 by 100. So we can cancel 7. 1000 minus 100 is 900. So 900 upon 9. So this 9 will be left here. So we are left with 4 into 22 into 9 into 10 to the power minus 6. In SI unit it should be in joule. Okay. So this will be 88 into 9 into 10 to the power minus 6 joule. So what I can do is I can bring 110 below this and 110 below this to reduce this to 10 power minus 4 joule. So this approximately 8.8 into zero point 0.1. If you take this as 1 instead of zero point 0.9, if you take this as 1, it will be 8.8. So slightly less than 8.8 into 10 power minus 4. So slightly less than 8.8 into 10 power minus 4 is this C option. 7.92 into 10 power minus 4 joule. Then moving to the next question. A thin rod of length 1 meter and cross section area this much is suspended vertically from one end. The rod is cooled from this to this degree. After cooling, a mass M is attached at the lower end of the rod such that the length of the rod again becomes 1 meter. Young's modulus and coefficient of linear expansion of the rod are this much. The value of M is. So here, as you can see, when a rod, when a rod is suspended from one end and it is cooled, naturally it will get compressed. But as soon as a mass is attached, that decrease in length is compensated by the increase in length. In other words, the reduction in length due to decrease in temperature must be same as the increase in length due to the weight attached at the lower end. Okay. So suppose this is the rod. Okay. Initial length is L and the temperature is reduced by delta T. So the length will be reduced by small l. So we have the formula change in length is equal to original length into alpha into delta T, where alpha is the coefficient of linear expansion. Then now in the second situation, a mass is attached at the lower end, so that the increase in length is again the same as so that it regains the original length. Okay. So here we have stress is equal to y into strain. Stress is equal to y into strain. Now from equation 1, let us substitute for small l here. This equation 1, I'll substitute for the small l. So that will become y upon L into L alpha delta T. L gets cancelled here. So mg by A is equal to y into alpha into delta T. So just substitute the values, that's all. Mass we have to find, acceleration due to gravity is 10. Cross section area is 3 into 10 power minus 6. 3 into 10 power minus 6 meters square. Young's modulus is 2 into 10 power 11 S78. Alpha is given as 2 into 10 to the power minus 5 and delta T is, you can see, just numeric value, okay, mod, you have to take the mod. So from 210 to 160 it is 50 degrees Celsius. So here 10 power minus 6 minus 5 is 10 power minus 11, which gets cancelled with 10 power plus 11, and 1 0 gets cancelled here. Then m is equal to 3 into 20, that is 60 kg. So answer is 60 kilogram. Then that's all students in this video. Thank you so much for watching my channel. Kindly subscribe to it and hit the like button. Thank you.